Hello everyone, my name is Rohit and I'll be presenting my presentation for CSC720. So this is an overview for our term project, introduction, ITTM and ITRM's implementation, computing PySets, ITRM, ITTM and halting problems, theorem, comparison and conclusion. So this is the introduction part of our term project. So infinite time register machines are the register machines which act as a natural number and which are allowed to run for arbitrarily many ordinal steps. And here we are not dealing with any negative numbers. The future steps are determined by the register machines. At a limit time, the register content is defined as a limit infinite of a previous register content. If the limit is a finite, otherwise the register is reset to 0. ITTM and ITRMs. Infinite time register machine are weaker than the infinite time Turing machine, especially for the halting problem. The ITRM halting problem is solved using ITTM. So earlier in our research paper, the machine halted or crashed when there is an overflow. So computing the PySets. So the idea behind computing the PySet is to keep track of a stack of the content. Here we are using a natural number, so we are taking a chain of a natural number, and we have a stack as in form of 2 to the power r0, 3 to the power r1 till pm, and whereas the pi is the ith prime number. We will be dealing with the operations like pushing, popping natural numbers, finding the length of the stack, and recursive and computable. The decreasing stack can also be computed by ITRM. Let us consider an example. For example, if P is a stack, P is a register and A is a stack with the operation like push, pop, length of the stack, decreasing stack, then predicate check the element. Here like we are setting the condition like true as a false as a flag. If the stack is full, then the condition will be true and then it will reset it to 0. So this is the implementation part for ITRM. Here we are using some instruction that we use in the class. So the 0th instruction. So it changes the content to 0 of that register and remain unchanged other. The successor step, it will increment the value of the register by 1, otherwise it keep it as a same. The transfer instruction. So it replaces the content of Rn by natural number and content by Rm and leaving the other same. The jump instruction compared the jump instruction compared the register and are left altered. So the URM proceed with the qth instruction. If Rm is not equal to Rn, then the URM proceed to the next instruction. So I'd like to hand over to my friend Yufan. He'll be explaining the further part.
Okay, hello, I'm Yufan. Now I will explain the main theorem of this machine. As you can see, there is a theme. This new theorem is impressed by the previous research of register machine because the ITRM is based on the following theorem of the machine. So the actors gave us a new theorem that is implied by the following theorem. As you can see, there is a full theorem that is ITTM, OTM, and ITRM and ORM. Here is the conversion. Here is the table of the conversion of the 3 papers. Of the ITRM, the first paper, there is only one theory, and the second paper adds 3 new theorems to solve halting problem and reach halting problem. The third paper has nothing added. The definition, the second paper, the first definition of the second paper is enhanced so that it can allow the problem is commutable when there is have single real number. Okay, here is the function of the ITM of the 3 papers. The first paper have 3 functions to compute the 1 number problem and admission set and infinite reason computation. And the second paper adds 2 new functions that it can compute 5 1 sets. The third paper has new function added. So here is the conclusion. In this paper, a study of ITM is described using 3 different published papers. The paper concludes use the result. We can say that ability of register machine to work with the real numbers. The ordinary machines are unbounded by time and space, where the ITRM and ITM are bounded by the space but unbounded by time. And the traditional machines, it is bounded by time and space. Okay, thank you, that's all.